I gave them a basic intro to geometric probability here, but it really always comes down to it's what you want. Wanted area out of possible area. That's how you do geometric probabilities. Well, you got to know a few areas. Like, for instance, if you don't know how to find the area of a rectangle or a circle or a triangle, we got to remind you about those because there's a lot of shapes that we could use on the test. These are the typical ones. Take a second, write down the area of those three things. Some of them are super easy. In fact, most of them are. And if you're grabbing a calculator to get the answer with a decimal on the circle one, don't. Leave pi in your answer because it's more accurate. You might think 3.14 is more accurate. It's not. It's rounded. Pi is not rounded, and therefore it's more accurate. So this one is just 7 times 7, so it's 49. And units are not going to be a big deal on our test, but it is square feet in case you forgot that little thing from geometry class. All right, radius, 3. That means from here to here is 3, and the area is pi, you remember the rest of it? R squared, good, and 3 squared is 9, so it'd be 9 pi. I know that you could multiply by 3.04, but don't because that's more accurate. Okay, and this one, 4 times 3 is 12, but it's not 12. It's half of that, so therefore it's 6 square feet. All right, could I draw a triangle on the floor? Oh, inches. It's got inches and feet, that's weird. I don't know if that was intentional. I think it was a mistake by the teacher, but if it was intentional, it was really misleading because do you agree that that does not look like it's 4 inches compared to 3 feet? That'd be extremely misleading, and I don't. In fact, the ACT promises not to mislead people like that. We would not want to mislead you on a test like that. This would be 3 feet then, or the other way around. Okay, 4 feet, 3 feet. You know, base times height divided by 2. All right. So here's a much more complicated problem because these are not really triangles. They might look like triangles and rectangles, but they're not. They're parts of a circle. Okay? If we were going to actually do this for this exact problem, we'd have to figure out what's the probability you stay in a circle. Because, see, that's going to be doable. If I actually asked what's the probability of hitting this little wedge right there, that would be a really hard problem because you have to figure out the area of that little blue shaded region, and that'd be really hard. You could do it, but it would be super complicated. So instead, what we're going to do is just think of these as circles, like landing inside this circle. Oh, then it's just circles. And then it's doable. Well, let's get the dimensions here. It says the bullseye is 1/2 inch. Does that say the diameter of the bullseye? Yeah, so the diameter of the bullseye is 1/2 inch, which means the radius would be not 1/2 inch. It'd be half of the half. You know what that is? A quarter, or 0.25, is your radius of the bullseye. Always go with radiuses because then it's easy. It works with the formula better. And the diameter of the whole dartboard is 15 inches. So that means like from here to here is 15 inches. Well, then we can do pi r squared and say what we want is that little area over what's possible is the huge area. And the area of the little circle would be pi r squared, but we know r. R was 0.25 or 1/4 inch. And then the whole thing was pi r squared again, but the r is much bigger on the whole thing. And the radius in the whole thing was 15. No, not 1/2 of 15. So what's 1/2 of 15? 7.5. Good. And now these pi's could cancel, couldn't they? And then it's just some calculator work and you'd have your answer. That's the probability of hitting the bullseye. But there's an element that we're not talking about. Would you agree if somebody's good at it, they have a higher probability of hitting that than just random chance? Okay, so we have to assume that the person like was blindfolded and dropped the dart and that they had like some kind of a tube that would guarantee that it stayed inside, you know what I mean? So it actually landed inside the circle. So there's a lot of things we have to do to make this random. On your test, you won't have to worry about that. It's going to be random. But I'm just trying to acknowledge the probability really isn't this. Because if the person's good at it, the probability is better than that. Move on. I made this problem a long time ago. I remember this. So you got this goat, and he's tied to the corner of a barn. Now, the goat can't go in the barn. It's walled off. So he's walking around outside the barn. And that means he's only got so much area that he can be in. Now, there's this small little section of dandelions. It's 3 feet by 5 feet. If you just take a snapshot of the goat at some random moment, and we also have to assume some things to make it random. We assume that the goat actually doesn't care about dandelions. He doesn't like them. Otherwise, he'll be in the dandelions because he'll be eating them. But we have to assume he just doesn't care about the dandelions. He's either in them or he's not. He doesn't care. He's walking around. If you take a snapshot of a random moment at the goat's day, what's the probability he's in the dandelions? Well, you might think this is super complicated because it's just part of the circle, but if you think about it for a second, would you agree that since that corner of the barn is 90 degrees, you can actually tell how much of the circle to chop out? So you just take the area of the whole circle, but then you be smart about that and go, well, he can't be in the whole circle. And what you want is super easy. You want to know about the dandelion part. That's super easy. What's possible is way harder. But figure out the area that you want over the area that's possible. Take a second. Try it. This is a typical test question. All right, what we wanted was this, and it's as simple as 3 times 5, so it's 15. That is incredibly simple. Deer King, way harder is what's possible. Is it just the circle? No, but you start with the circle. So what do you do with that? Yeah, so what's this area of the circle? There you go, pi r squared, and r squared is 10 squared, which is 100 pi. Good. Now that would be if he could be in the whole circle, but he can't, so what do I do? Yes. What's the math way to do that? Multiply by 0.75 would totally work, yeah. Now, if I just multiply that 0.75 times the 100 in my head, I can do that, right? Jonathan, what should I simplify my fraction to?
1/5 pi.
Isn't it? Oh, you've simplified it way further than me. Did you start with 15 over 75 pi?
Yeah.
Awesome. And then that reduces to 1. Oh my gosh, you knew that 15 went into 75. Nice. 1 over what?
5 pi.
You are correct. Nice job. Now, wouldn't that feel better if it was a final answer as a decimal? It might. So at this point, you could, on the test, your answers are all going to be decimals again. They're going to be decimals to 3 places again. And at this point, you'd have to do something for pi. And so if you use the pi button, it's going to be slightly different than if you use 3.14. Just let's all agree to use 3.14 because everybody can do that. Not everybody has the pi button. So take a second, figure out your final answer as a decimal. You can use your iPad's calculator. You can use a physical calculator. I don't care. Just use a calculator. I got 0.06369. Raise your hand if you got the same thing to start with at least. Okay, good. If we go to 3 decimal places, that's my favorite way to do it. And then I just decide, is it that or should I round it up? In my opinion, there's no such thing as round down. I mean, okay, there can be, but we don't ever do it. We could cut it off like this, that's called truncate. Or we could round the normal way. In this case, 0.064. And if you wanted to say it as a percent, you're making your life harder, but you could say 6.4%. But I'm perfectly good with these answers. I noticed some people used 6.4%. That's fine, but you're doing extra work you don't have to do. 0.064 is a right answer. That's the probability. Because technically decimals are, the answer to any probability question is supposed to be a number between 0 and 1. And 6.4% is kind of like not really what you're looking for. It's 0.064. That's a number between 0 and 1. And it is true, that's the percentage chance of hitting that spot. All right, good enough on that. I think you get the idea. Now it's just going to be different combinations that are going to make you think more. And if every time you figure out what you want and put it on top, and all the things that are possible, put them on the bottom, these will work out. So let's talk this through. The game board for a carnival game is shown below. That you're able to flip a coin and have it land on the board. What's the probability of it landing on a yellow section of the board? All right. You might be like, well, I don't have a formula for figuring out those little diamonds. You don't really need that. You need a formula for figuring out the whole thing, and you need a formula for circles. And you need to be able to figure out how to get the shaded region. I'm going to give you a much simpler question to start with. If I just had this rectangle, and then there was a circle covering up this part of it, and then I said, what's the area of the shaded region? Do you get fundamentally, it's the bigger area minus the circle? So it'd be the rectangle minus the circle. The shaded region is you take the bigger area minus the circle that's inside it. So if I had lengths, this was 10, and let's say this was 8, and that would make this radius, because I can use math here, if that's 8, this must be 4. I could know the radius was 4, right? And then I could go the area of the shaded region, the bigger one, which is 80, minus pi r squared, 16 pi. So the green shaded area would have been the rectangle minus the circle, which would be 80 minus pi times 16. All right, back to this. Can you do math and figure out that each of these diameters must be 1 foot if the total is 4 foot? So then you can figure out that each little circle's radius, you need the radius in the end, is not a foot, it's a half a foot. 0.5 is the radius, right? Take a second. Figure out what you want, which is the yellow region, which is something minus something, over what's possible, which is the whole big rectangular retch. They never said this, but they kind of implied it. If that's 4 feet, this must be 4 feet too. I mean, it has to be if the way they drew it out, but. Okay, take a second. Actually get the decimal for this. And what you want involves subtracting something minus something. What's possible is easier, much easier. And get your final decimal answer, and please compare it with the kid sitting next to you. Okay, would you agree that what was possible was you could have landed anywhere? And that's 4 times 4 is 16. Raise your hand if you had 16. Good. On the top, what you want is the yellow area, which is how big? Well, it's really small. It's the 16 minus all those circles. Not just one circle, all those circles. There are 16 circles, right? I got to take away that area of the circles. 16 times pi r squared, and pi times r, the radius of each circle is 0.5. squared. And that is your answer. Now it's just a matter of getting the decimals for those things. So on the top, does anybody actually have what the top came out to? Because the bottom's clearly 16. How about the top? You got it? Summerfield.
It's 3.44.
Can anybody verify 3.44? Multiple people are raising their hand. Good. And then if I actually divide those two, what is 3.44 divided by 16?
3.44 divided by 16 is 0.215.
0.215. Raise your hand if you had that one right. Cool. That's a pretty complicated problem. So your probability is 0.215. If you wanted to say it as a percent, you could. It'd be 21.5% chance. All right. One more without my help. Read it. Try it with no nudges from me. I'll pause while you give it a shot. We're pretty much done, folks. It's good news. Be in your homework in seconds.
Seconds?
Well, maybe a lot of seconds, but definitely seconds. All right, so here's how I'd approach it. That's why I started with this. When you get stuck, always come back to what do I want to happen, and then what could possibly happen. And in this case, it's all about areas, so it's the wanted area. One of the openings. Okay, so any of those could work. So I have to add up two circles. 2 times pi r squared, but radius is 2, so 2 times 2 squared, which is 4. That's my two circles. Plus the triangle, which is 3 times 5, but then cut it in half. 1/2 of 3 times 5 is 15. That's my triangle. And then plus the other thing I want is the 8 times 2 is 16. There we go. There's the top. What was possible is everything, which is everything on the board is 10 times 20 is 200. So if you divided those, you did it right. Raise your hand if you did it right. Any questions? Let's actually get the number here so you can have the, satisfaction of knowing you did it right or not. Rohan, what did you get for your final answer? Decimal.
I messed up on one.
Oh, okay, all right, fair enough. Thanks for being honest about that. Zeke, did you get a decimal answer? 0.243. Can anybody verify 0.243? Lots of nodding heads. Yay. Okay, cool. All right. That's it. That's all you got to do. That is about as hard as they possibly get. If you got this problem right, you've already got this section of the test right. On the next test has a section on geometric probability. All right, so let's get to the assignment for today. Everybody find it, open it up. All right. So there's a Schoology quiz, and I'm seeing question 1. It's got a big circle, which is 36 inches across. And it's got a bunch of squares in it, 4 squares that are all the same. And they're 5 by 5. Now I got to figure out what I want and what's possible. In the circle, but not in a square. All right, so what I want is this shaded region that's in the circle, but not in a square. Remember that to do that, you find the area of the whole thing, which is 36, so it's pi r squared, so it's pi times 36 squared. And then I take away the squares that I don't want to hit. And there's 4 of those. And they're each 25. 5 times 5. There we go. That's what I want. See how I got that? Area of the whole thing minus the 4 squares. Now what's possible is everything, which is the area of the whole thing. Pi times 36 squared. It'll take you a minute using your calculator to get all those decimals. Once you do, I'm just going to double check it. I'm not gonna tell you the answer, but I'm gonna tell you the answer is like 0.913. That's not the right answer, something like that. I'm not telling you the right answer, you figure it out. But it's something like that. Yes.
Isn't it 36 in diameter?
Oh, good catch. Thank you. It is not 36 squared. It's half of 36. I think that's 18, isn't it?
Yeah.
Thank you. Good catch. I'm sure somebody else was thinking it, but they didn't have the boldness to say it. Good catch. Okay. And again, the answer is not 0.913. I'm just saying it's a decimal like that. If you want to, you can always check with the kid next to you. All right. There's 3 blanks that they want for this. That's the first answer. Starts with a 0.9 and then has more. Okay. That was the first answer. The second question they asked, it lands in one of the top 2 squares. Well, what do you want? I want those 2 squares. 2 times each square is 25. What's possible? The whole thing. Pi times radius, which is 18 squared. Let's get the decimal for that, and you got it. I'll give you this hint. It starts with 0.0 something. Yes?
So on the Schoology quiz, do you want us using 3.14 or can we use pi?
You mean the pi button?
Yeah.
How about this? The most difficult answer. Did you get the first blank? Did you get the answer for the first blank as a decimal? Yeah.
Oh, yeah.
Okay, what did you get? And did you use a decimal, 3.14, or did you use the button?
I used the button and I got 0.902.
Okay. Did anybody use 3.14? Did you also get 0.902? All right, cool. Then it turns out that the button or 3.14 gets the same answer. Obviously, we know that if we get out enough decimal places, it would be different, right? But apparently, it's accurate enough that you could use the button.
And then also I have another question.
Sure.
On the third question, should we put it in inches or feet?
It's a probability, so it won't matter. I know that seems weird, but if your top is in inches and your bottom ends up in inches, then when you divide them, you'll get the same answer as if you do the problem in feet, because the feet will cancel or the inches will cancel. So it won't matter. Whatever's easier. Because at the end, it's a decimal. It's not a inches or feet thing at the end. It's because they cancel. All right. Cool. From here, you have a fair amount more work time than normal, but it's kind of a, it's just 5 questions, but they have multiple parts, so it'll keep you busy. And I don't think I've handed your test back yet, have I? All right, so then, did we take that literally on the last day of school? Right before break? Or I remember it was like you could take it the day before
Yeah.
or the day or the last day. Yeah, got it. That's why I was like, I felt like I could have handed them back, but I really couldn't because people were still taking it. So I've got those tests for you. I'll hand those back in a second.